Hello and welcome back to lesson 4.2. Today we're going to be looking at how to graph step functions and also absolute functions. So step functions and absolute functions, graphing, are really just a special version of a piecewise function, which we talked about in the previous video. So let us today look at what is a step function, identify both the similarities and the differences between it and a piecewise function, and then we're going to evolve into what is an absolute value function, something we've seen before, we saw before, but now let's see how do we graph it and manipulate it. So first off, let's start about with a step function. And specifically, a step function is a very specific type of piecewise function that might look something like this as an equation. Now if you notice in this equation, we again have our restrictions on our x's, our intervals are our domains for our x's, but the parts that we're graphing now, there are no x values out, they're all constants. And well, what this is going to end up looking like or representing would be something similar to a price structure, if you would think about like going to an amusement park. There's a child's price that might be, let's say, $10. There might be the adult price that's like $20, and then there might be the senior price that's $15. So at the various different stages, you have some different prices. And that's sort of what this is going to look like. You're going to have some horizontal lines at various parts that are just going to move around according to the x values. So if I were to go to graph this, and we can use any of the techniques from the prior piecewise function, whether it's that table of values, whatnot, we could graph them. But really, what I'm going to do is this first equation, I'm going to graph it so long as x is less than -3. Now, if the equation is just -2, what is that line going to look like? Well, for step functions, that line is just going to be a horizontal line. So for that first equation, I'll make in blue. We'll start at -3 as the x value. And we're going to use that equation while x is less than -3. So there is that first equation. When x is -3 or less, open circle at -3, and it's less, that value is going to be, the y value is going to be -2. So let's try the next one. If the x value is between -3 and +2, x value is between -3 and +2, the y value is going to be 1. So the y value is going to be 1 from -3 to +2. Again, it's just going to be a horizontal line. The y value is 1 all throughout that. Now do notice my open and closed circles. There's a closed circle at the 3, an open circle at that 2. Closed circle at that 3, an open circle at that 2. Now if I do that last equation, I am going to graph the line at 3, while x is greater or equal to 2. So 3. And there we go. That would be this piecewise function or this step function graph. And you can kind of see it does look like you have these stair steps. Step 1, step 2, step 3. These look like these do have those steps to them. That's why they call them step functions. And again, hopefully you can kind of see how these would relate to maybe like prices at a amusement park or a movie theater. Like there's the kids price, the adult price, the senior price, and they sort of vary as they go along. And there's different ways you can look at it. But regardless, it is these horizontal lines at -2, +1, +3, that we're going to graph at different intervals. These are our step functions. So that is the short version of what a step equation is. It's nothing more than a special type of piecewise function, but instead of there being a variable that we have to graph with, the line's not now just going to be horizontal on its parts. If you wanted to, again, use your graphing calculator and grab those table of values, you could, again, if you wanted to graph that first equation, you could say, all right, -2. You could go to the table of values, like we did in the piecewise function, and you can say when x is less than 3, you can scroll, and you can just plot those points. The table of values would also work for that, but just realize when we graph it, they're just going to be some horizontal lines. So part 1 today is just graphing a step function. Again, it's a special type of piecewise. Now part 2 today is can we graph another piecewise function. And now this is going to be a special piecewise function that's going to end up developing into our absolute value equation. So again, we have a piecewise value here, piecewise equation. If you want to use your calculator, you want to do some plugging in, it's up to you. But we're going to plug in these x values into our equation, and we're going to get those points out, and then we're going to try to graph them. So if you want to, at this point, pause the video, try creating that table of value yourself, and or create the graph by yourself. Please do so, but I'm going to go ahead and do that now. So negative 3 goes into the first equation, negative 3 is a 3, negative of negative 2 is a 2, negative 1 is a 1. This, depending on which equation we plug it into, is a 0 or a 0. Awesome, so I'm going to plug in my points. Negative 3, 3, negative 2, 2, negative 1, 1. Open circle there. Next equation. So we have, if I can make that line a little bit straighter, that'd be nice. 1. Now something to note here on this equation. Well, 1, this is going to be our piecewise function. It's going to be essentially the absolute value function. Is what we're graphing. The absolute value is just a special piecewise function. But also notice how these two equations, where one equation ended, the other began, so that's just a dot right there. But this is actually the absolute value function. It's just developed by these two parts. It's just a special piecewise function for us to graph, and it is something useful to see. Now, moving forward into our next video, we're going to take this absolute value function, and we're going to see how we can manipulate it, or rather transform the graph up, down, left, and right based on this original graph. I would recommend getting used to seeing what this graph looks like. This is what we're going to refer to as the parent graph of absolute value. It is going to be something useful to be used as we move forward. Have a wonderful day. Take care, be well, and I'll catch you in the next video.